Hello, everyone, and I'm here to tell you a little bit about why I think continual learning agents are extremely important if we want to start understanding how to have energy efficient systems and smarter systems going forward. And I think this is an important social good. And my name is Martha White, and I'm an associate professor at the University of Alberta. So the setting I'm always imagining is a continual learning system like this one. So imagine you have an agent that's continually optimizing operation of a drinking water treatment plant. And so you have this robot here, and it's going to be making a lot of decisions about different control points in this drinking water plant. So this is an actual application that my group is working on, and this is what a drinking water treatment plant looks like. And so, for example, here you might have an inlet tank here that's full of all the water coming from the river, and you might need to make choices like, well, how fast should I be mixing the water in this tank? How many chemicals should I be adding to the tank? And then once it's going through the filters, you'll also sometimes need to clean those filters. And so you have to push the water back through the filter to blow stuff off of that filter. That's called backwashing. And there's all these different choices when we're doing backwashing. So, because the system is quite complex and it's full of lots of different changing choices, it's naturally set up for a learning agent, and particularly using a technology called reinforcement learning. That is my research area. Okay, and so one of the main points I want to get across today is that lots of systems like this, traditional industrial control systems are quite static, and there's naturally a reason for this. And here, when I say a static system, what I really mean is a non-learning system. So let's think about what it would mean to have a static system here for drinking water treatment. So to set up a drinking water treatment plant, again, it's this big complex system. An engineer needs to come and decide on lots of important parameters, and those parameters are going to be different for each location. So they'll have a phase where they'll decide on parameters like what are the parameters for cleaning these filters that I mentioned for backwashing. So maybe they'll select some schedule or strategy for doing mixing speeds. They'll select certain aeration levels, and there's just a lot of other parameters that need to be set. So really, there are too many parameters for the operators to be constantly adjusting later to try to improve operation of the system. And so really only a small number of things are adapted once this has been deployed. For example, they'll often check things like how much chemical should be added to the water, but they're not going to be fiddling with all these other low-level choices that could be adjusted. So in fact, when we have all these low-level choices, this is exactly a case where we want a learning algorithm, one that can monitor many sensors and actually make a lot of these choices at a more fine-grained level. So one of the issues with having static systems, of course, is that the conditions are going to change over time, and the what was good in deployment isn't necessarily going to be the most efficient strategy later. The filter is going to degrade, water conditions are going to be different in following years. The operators might even modify how they actually do maintenance. And it's unlikely that whatever those first initial set points were are actually going to let the system run as effectively as it did initially. So naturally, being able to constantly adjust these parameters after deployment is just going to be a more energy efficient thing to do. So an agent that is continually learning can, of course, adapt to these changes, is my point here. Okay, but naturally, when we start talking about having an agent continually adapting, the very first reaction I often hear is, isn't it dangerous to deploy a learning system? It's very different from what we do, and it seems a little scary. We don't actually know what this learning agent is going to do. What if it starts going haywire or does something a little crazy? So I want to point out that learning systems should actually be safer. And executing a static procedure is inherently more unsafe. So it would be like having a human operator, taking care of this system and always running the exact same procedure, regardless of actually what they notice is happening in that system. So static behavior isn't something we actually expect from people. We expect people to adjust and see how they should be changing their behavior to do a better job. And we should be expecting the same thing from our learning systems. So adapting is inherently safer because as things change, you continue to act sensibly. Whereas if you continue to execute a rote procedure and not adjust to these changes, you might actually perform very strange behavior. So it's kind of obvious when you hear it, I hope. But nonetheless, that feeling stays. So why do we feel that static is safer? So I feel like there's three reasons for this. One is we're just comfortable with the status quo. This is how our systems work today. They work pretty okay. We have drinking water, and so we're just comfortable with status quo. A next point, of course, is that engineers have been testing these current solutions for many years. So, of course, they've worked out a lot of issues with them, and we, again, understand some of these solutions quite well. And I think a really important third point is that our automated systems are currently limited to those where engineers can actually be confident about the behavior of that system. So maybe you're in a relatively controlled scenario, like you have a robotic arm in a factory, and now that's a setting where we can be more confident that having static behavior is actually going to be effective. So to me, once we start asking, how can we tackle more complex problems? We have all these problems that in the world that we want to start getting better at optimizing. So in order to actually do that, we need to start looking at learning solutions, because non-learning solutions will no longer be effective. And what I think that, that's sort of the longer term goal. And today, what we should start doing is replacing some of our static systems with learning systems and start getting a better idea of what is actually feasible to tackle. Some things we may need to leave static because our algorithms are not yet ready there, but we'll start getting a sense of what are the limits of what our learning systems can actually do. And I think it's really important that we start doing that today, because there's status quo is no longer going to be acceptable. We're wasting resources and energy, we're harming the earth and people. And so a lack of inaction here is actually harmful in itself. So for example, even if we can make our systems only 10% more efficient, then we must do that. It behooves us to do that. Okay, so I hope I've helped you think a little bit today about how learning systems could help us actually have AI have benefit. AI is going to help us make our systems smarter and more efficient. And that just means that we're going to be smarter with our resources. All right, thank you very much.